Okay, with respect to the origin, this is quite a long question. The point A has a position vector 1, 3, negative 4. The point B has position vector negative 12, 8, and 4. Right, so negative 12, 8, and 4. Right, point A is 1, 3, negative 4. Right, from here, point P lies on the point OA. So this one thing we can help us to draw a diagram. Q and R are such that PQ equals to 1 plus QB, OR is equals to 5Q. Our first task is to show that R lies on the line whose vector equation is equals to negative 15 plus 10 plus 5 together with 1, 3, negative 4. Right? So here, right, the only thing that gives us a hint about where R is, right, is actually, you look at the question carefully, right, it's actually this line here, where OR equals to 5OQ. Right, so let's say if we don't know how to even start this question, one good way to look at it is to actually just maybe draw the diagram first. Okay, and we see some ratio going on, so maybe we suspect that maybe a ratio theorem might come in handy lah. Okay, we have the point A is 1, 3, negative 4, so maybe let's just draw O, right, and we draw A. Okay, we draw A. Okay, this one is A. Alright, this one is 1, 3, negative 4. Okay, then we also have B. Maybe B I use a different color. So this one is B. Okay, and the point P lies on OA, so maybe the point P I can put it somewhere here. This one is point P. Okay, and then the point Q and R are such that PQ is 1/3 of QB. So let's think about ratio. PQ is 1/3 of QB. Right, so PQ, so assuming, let's say if I put Q to lie somewhere, let's suppose I want a line between P and B, right? Right, so let's say if I put maybe PQ somewhere here, 1/3 of QB, that's also a possibility. I mean, this may not be the one of the only way to draw this diagram, but I mean, there's one way, right, to show that PQ is 1/3 of QB, right? And OR is 5 of OQ. OR is 5 of OQ. So let's say if I were to use another color, right, this is OQ, right? So OR might be going all the way 2, 3, 4, 5. I mean, so let's OR could be somewhere here, right? So next thing I want to do is I want to show that R is on the line whose vector equation is PQ. Sorry, is equals to negative 15, 10, 5 plus theta 1, 3, negative 4. Okay, so the only way to actually even start this is to first, you see the only thing that gives us any hint about R, right, is actually our Q. This is the one that gives us the hint. Alright, so how do we start doing this? Okay, how do we start doing this? First, maybe using ratio theorem, let's try to find OQ. Okay, so OQ, right, we know that PQ is 1/3 of QB, so here the ratio here is 1:3. Okay, so using ratio theorem, right, we can try to find what is our PQ. Okay, OQ, sorry. So using ratio theorem, okay, we know that OQ, right, this is just equals to 3 of OP plus 1 of OB, right, over 3 plus 1, which is 4. Then that gives us a problem because we know that we don't have an answer for OP, right? So maybe what I can do is we go back to we just work backwards and say, because we know that OP is a scalar multiple of OA. So we just say maybe a OP equals to maybe a scalar multiple of OA, right, where lambda is a real number. Okay, so over here we can say that OQ, right, is the same as since it's 3 of OP, right, so OQ over here is the same as 3 of OP. Okay, OP as we sorry, not 3 of OP, 3 of OP. Okay, so 3 of OP, so it's 3 of lambda, right, or OA is 1, 3, negative 4. So this is the OP. right? Plus 1 time of OB, and our OB is just negative 12, 8 and 4, alright? Negative 12, 8 and 4, okay? Multiplied by 1, and if we divide this by 4, that will actually give us, if we simplify this, divide by 4, this gives us negative 3, divided by 4, 2, right, and 1, plus 3 over 4 of lambda, 3 over 4 of lambda, right, 1, 3, negative 4, right. So we first, let's just deal with this discomfort that our OQ doesn't look so nice, right. And then from here, right, since we know that OR, the question tells us is nothing but the question tells us that OR is 5 times of OQ, right. This means that OR is nothing but 5 times of your negative 3 to 1 plus 3 over 4 lambda 1, 3, negative 4. Okay, and so with that, we can actually write our answer. So since 5, we can just write it as 5 times negative 3, negative 15, 5 times 2, 10, 5 times 1, 5. Right, so we have our position vector. 5 times 3 over 4, so you just distribute this in here, distribute this in here, then we have 5 times 3 over 4, so we have 15 over 4, right? So this is 15 over 4 lambda of 1, 3, negative 4. Right, so you go back to the question, we wanted to show that it can be written in this form, negative 15, 10, 5, okay, almost there, 1, 3, negative 4. So you come back here, yep, actually we are almost there. All you need to do just rewrite this, let this be theta, and then we have actually showed the question. So we just say this is negative 15, 10, 5 plus theta 1, 3, negative 4, okay, where theta is equals to 15 over 4 lambda, and we are done. Okay, so with that, okay, we have showed that tens R lies on the line L. Okay. So for part 2, okay, for part 2 we have this plane. This plane contains a line and is parallel to the vector 11, 7, 8. So we have our plane. So our plane contains our line. Right, remember the line that we found earlier? Right, so the line that we found earlier was negative 15, 10, 5 plus the 1, 3, negative 4, right? Okay, it also is also parallel to another vector 11, 7, 8. Okay, so we can use another vector which is here. Right, so this one is 11, 7, 8. So it doesn't, remember that for direction vector, it doesn't have to lie on the plane, it's just parallel to the plane. Alright, so next, the line through A perpendicular to P meets P at L. So there's this line, okay, so there's this A line in space, supposing that there's this A, right? So the line that passes through A, right, perpendicular to P, right, supposedly meets P, this is our P, right? This is our P, right? It meets P at L. So now there's this L. There's this point L that we need to find. The line passing through A perpendicular to P meets P at L. So find the position vector of L. Okay, so here, right, one of the things we can do is, okay, looking at the one in green, right, what we can do is we can find, first, right, we find the vector equation of this line. Okay, after that, right, all that means is we are actually, looking at your lecture question is the case of finding the point of intersection between the line and the plane. Okay, so I say again, number 1, what we do is we find the vector equation of this line. Number 2, this is us actually solving the point of intersection, between line and the plane to give us L. Right. So first, how do we find the vector equation of the line? Right, the vector equation of the line, okay, number 1, we have a position vector, right? Number 2, what we need is we need a direction vector. We need a direction vector for the green color line. how do you find a direction vector for green color line? Okay, we can see that first, the hint is that they tell you this line, right, is perpendicular to P. Perpendicular to P means what? We can actually use the normal vector. We can use the normal vector of the plane, right? It will also give us a direction vector of the line. So the normal vector of the plane will give us a direction vector of the line. So number one, quickly, how do we find the normal vector of the plane? Okay, so let's say we go back to our question. We know that we have P, right? Okay, so the equation of a plane, let's say we write it in a parametric form, right? So it's negative because it contains the line L. This is the position vector of the plane, right? It contains the line L, so we can know that it contains this direction vector. It's also parallel to 11, 7, 8, so you can say that our parametric, our vector equation of the plane in parametric form can be written in this way, right? So back to your lecture question, you know that if you are going to find a normal vector, okay, this is like A, this is like your M1, right? This is like the M2, right? So if we want to find an N normal vector, what we do is we just take M1 times M2, right? That will give us our normal vector. Okay, that's the idea behind it, huh? So with that, right, we just take 1, 3, negative 4. Sorry, not plus. It's a vector product with 11, 7, 8. Okay, then this one will give us the normal vector to the plane. Okay, so I'll leave you to solve this by yourself. You will get 52, negative 52, and negative 26. So always have the good habit of factorizing your normal vector, for factorizing your vectors, your direction vector. Always factorize it. Okay, so you can use this. Alright, and we can say that a normal vector to the plane is just 2, negative 2, negative 1. Alright, so this is a normal to our plane here. Okay, simply by taking the vector product of our two direction vector. Okay, with that, right, why are we finding this? Because this 2, negative 2, 1, right, is here. This is 2, negative 2, 1. Negative, sorry. It will help us to find the green color portion, to find the vector equation of that line. Alright, and from there, right, we can say the vector equation of the line, right, using the normal of the plane. Alright, okay, let's say just call it AL, right? Okay, because simply this is A, this is L, so vector equation of the line AL, right? R is equals to 1, 3, negative 4, right? The position vector of A plus I have used lambda, I have used determinant, I use mu lah. Okay, normal vector 2, negative 2, negative 1. Right, this is the normal vector of the plane. Alright, it becomes the direction vector of the line. Okay, right, from here we have the vector equation of the plane. Okay, and going back to the vector equation of the plane, I can also write it in this way. I can also say that the vector equation of the plane, right, since it's just R dot product with the normal vector, 2, negative 2, negative 1 to be equals to negative 15. So this is A dot N, right, dot product with 2, negative 2, negative 1. So this one is the A dot N in our equation, right? So this will give us negative 55. Okay, so with that, right, from here, solving for the point of intersection actually is no longer difficult. Okay, so we very easily, what we do is we try to sub. Okay, we try to sub. So since L lies on both the line AL and P, right, it must satisfy both equations. Okay, meaning L also can be expressed as 1 plus 2 mu, 3 plus minus 2 mu, minus 4 minus mu, right? So if I write it this way, that means if I were to express it, sub into the plane, right, 3 minus 2 mu, minus 4 minus mu, if I dot product with using the plane, sub into the plane, right, negative 2, negative 1, this represents my xyz on the line. This represents my xyz on the line, okay? And sub into the plane, it should also give me the same answer. It should also give me okay, it should also satisfy the equation. And from here, right, if I solve this, okay, I hope you can do this by yourself. Your mu will be negative 55 over 9. Okay, after this, so negative 59, this parameter mu here gives you the mu where L the point of intersection. So from here, right, you just sub it back. Okay, R equals to 1, 3, negative 4 plus negative 55 over 9, 2, negative 2, negative 1. Alright, so you should have your OL, right, your position vector of OL to be quite an ugly number. So negative 101 over 9, 137 over 9, and 19 over 9. Okay, it's quite an ugly number. Huh? Okay, yep, and that's the position vector of L. Okay, so next, we want to find the position vector of the reflection. Okay, the reflection of point A about the plane P. Okay, so it is as though, example, if we were to look at something like this, right? So maybe this is the plane P, right? So this is the A, right? This is the A. Remember, this is the L, right? Let's say we look at it from the frontal view, right? Then, so the reflection is somewhere here. This is our A prime. Okay, maybe I draw a bit further now. This is the A. So maybe what I do is maybe I let A prime be the position vector. Okay, or maybe the point of reflection. Okay, then to find the A, actually it's not difficult. Actually, if you think about it, point of reflection means what? They are symmetrical. Right? So if I look at this, it's like the ratio is 1:1. So let's say if I use ratio theorem, so very easy. I just very quick can see that OL, right, actually, right, it's just OA, 1 of OA plus 1 of OA prime over 2. This is using like your point of reflection. Okay, using ratio theorem. Right, using ratio theorem. Okay, and since we already have both OA and OL, we know OL is just equals to negative 101 over 9, 137 over 9, 119 over 9, right? Right, this is equals to OA. OA we know is 1, 3, negative 4, right? Plus, plus OA prime divided by 2. So what remains just for you to manipulate this equation. Okay, so you just bring the 2 over, right? Bring the 2 over, right? Minus 1, 3, minus after you bring minus 1, 3, negative 4, correct? You just cancel this, and then you can get your OA prime. Okay, so solving everything, okay, I hope you do by yourself. Your OA prime will just give you negative 211 over 9, okay, 247 over 9. I hope you can do this and really verify it that you can get it correct, and 74 over 9.